This is planet Earth at the center of a time and date-telling celestial sphere. Let's go all the way around it. This is the southern hemisphere, and we're going back to the northern hemisphere. My name is Keith Whitten, and I'm the inventor of the Monad Calendar Clock app. This is a screen recording of me operating the Stage 2 Monad app, the prototype, which you can download from the App Store for $1. And note that you can see the gestures I'm using, dragging, tapping, pinching. This is my very first Facebook video, and it's going to be on the subject of how the Monad Calendar Clock compares to a regular clock. Tomorrow I'll post part 2, how the Monad Calendar Clock compares to a regular calendar. So here we go. Part 1, comparing the Monad Calendar Clock to an ordinary clock. Alright, so this structure here, this white wedge-shaped structure, is the hour hand, and this is the time dial. And note that it's a 24-hour time dial instead of a regular 12-hour dial. Monad automatically places a time zone spanning hour hand at your location on the globe. This is the hour hand right here, and I'm located here in Northern California, so that's where my hour hand is located. This is the West Coast, that's the East Coast of North America. Let's back up a little bit here and note that if the hour hand is pointing at the number 12, in this case, that means that where the hour hand is located, that time zone, that it is noon at that time zone. You see all 24 time zones all around the globe at the same time. Now note that in Northern California, or the northern hemisphere of Earth, that the hour hand advances in a counterclockwise direction. So I'm going to set this in motion. And note that the hour hand is going counterclockwise here. 6 o'clock, 8 o'clock, 10 o'clock in the morning. There it is, noon. And let's bring it back to now. And let me just point out that you've also got a what I refer to as a twilight dial here, which shows the time of sunrise and sunset, where it turns from black to white on the dial. So at this latitude in Northern California, the sun rises at a little bit after 7 and sets at around 5 o'clock in the afternoon. So let me show you what happens if you change the location of the hour hand. So we're going to use these sliders at the bottom, change the longitude. Let's shift this hour hand over to there, and then let's move it up northern. So we're now at 54 degrees latitude. That's getting closer to the poles. And here we are in Newfoundland and Labrador, Canada. And at that location and latitude, it's now almost 4 o'clock in the afternoon. Sun sets in about a half an hour, and sun rises at about 8 a.m. So now let's hit the here button, and we'll go back to Northern California, where it's 4 hours earlier, still noon. Sun rises at 7:20. And sets at about 5 o'clock in the afternoon. These are the 4 corners of a solar day: sunrise, noon, sunset, and midnight. Now, let me speed things up, and I'm going to show you the impact that the time of year has on sunrise and sunset. So watch the twilight dial here as we really speed things up. See how the twilight dial is changing the time of sunrise. We're approaching The date here is June, so that's the summer solstice right there. And that's when you have the most daylight versus nighttime. So the sunrise was the earliest then, and now it's approaching the equinox right there. And we're approaching once again the the winter solstice at December 21st, right there. All right. As you can see, the difference between an ordinary clock and the monad calendar clock is the difference between night and day. In our next video, I'll show you how the monad calendar clock compares to an ordinary calendar. Thanks for watching.